Hi, in this lesson we're going to look at a bunch of problems involving trigonometry where we have to apply the sine law and the cosine law to problems in both 2D and 3D. That's problems in 2 dimensions and 3 dimensions. In this first video we're going to look at a problem where we're told point P and Q lie 240 meters apart on opposite sides of a tower. The angles of elevation to the top of the tower from P and Q are 50 degrees and 45 degrees respectively, and it wants us to find the height of the tower. So I always recommend that when you are solving a word problem involving involves triangles, or anytime you're solving a word problem in math, in trigonometry or geometry, and there's no diagram drawn, try to draw a diagram if possible. That's something that really helps you a lot. The other thing that I always recommend is to always read the problem carefully, and if you don't understand it, and if you're not able to pick out all the details in the first read through, read the problem again, because sometimes there's details that you've missed the first time that you read the problem. So in that case, I would recommend to read it again. So let's go ahead, we'll draw out a diagram. So here it says point P and Q lie 240 meters apart. So let's go ahead and draw that out. So let's draw out P and Q such that they're 240 meters apart. And it says that the angles of elevation to the top of the tower from P and Q are 45 degrees and 50 degrees respectively, or other way around, 50 degrees and 45 degrees respectively. So let's go ahead and we'll draw this tower, and the tower looks something like this. Actually, you know what? It's going to look something more like this, because the angle from P is 50 degrees. The angle of elevation looking at the tower from point P is 50 degrees. So that's basically the angle that if you were on the ground, it would be the angle that you'd have to look up at to see the top of the tower. And from Q, the angle of elevation is 45 degrees. Now this diagram is definitely, it's definitely not to scale, because this triangle here is definitely not, like this angle is definitely not 50 degrees. And this angle is definitely not 45 degrees. So this triangle is definitely not is not to scale at all. If it were to be to scale, we draw more like this. It would have to be a little bit, probably a little bit higher. Okay, so that's probably a little bit better. There we go. So this is about 50 degrees, or this is 50 degrees. This angle is 45 degrees. And the height, since we're drawing the height, we assume that the person that built the tower so that it was a vertical tower. So we're going to assume here that there's the tower isn't leaning at all. So this is a 90-degree angle. And now we're tasked with figuring out what the height of the tower is, and the height is this dimension h. Now there's a couple different ways to do this problem. I could technically write a system of equations and use the tangent ratios here, or another method that I can do is let's label this this top point PQ. Let's label this as R. So now we have triangle PQR. So notice that if I know either side Q, or if I know side P, I'm able to get the height of the tower, because P times the sine of 45 is this height here. So one way to do this is to set up two equations, because like represent this distance as an unknown distance. I could call this distance x, and then I could call this distance 240 minus x. And now I've got two unknowns in triangle, in this triangle here. So in this triangle I've got two unknowns, and I can set up an equation, because I can say that the tan of 50 degrees is equal to h over x. And then I know in this triangle, this other one, this 45, 45, 90 triangle, that 240 or the tangent ratio of 45 degrees is equivalent to h over 240 minus x as well. So I have that tan of 50 is equal to h over x, and tan of 45 is equal to h over 240 minus x. That would give me two equations with two unknowns, and then I could use substitution to actually solve that system of equations. Now, that's definitely not the fastest way to do this this question, I don't think. Probably the fastest way to do this question is to use the sine law and figure out, try to figure out what, we know what this angle is here. So we know that this angle R, angle R is equal to 180 degrees minus 50 degrees minus 45 degrees. And 180 minus 50 degrees is 130. 130 minus 40 is 90 degrees, minus 5 is 85 degrees. So we know that angle R is 85 degrees. So let me just label that angle. So angle R is 85 degrees. Now, we know that the sine of, we know that side R, which is 240 degrees, the ratio side R divided by sine of R is equal to side P divided by the sine of angle P. And I know what R is. R is 240 meters, so I have 240 divided by sine of 85, because angle R is 85 degrees. And that has to be equal to P, side P, over sine of angle P, which is 50 degrees. I can isolate for P by multiplying both sides of the equation by sine 50. And I get that P is equal to 240 sine 50 degrees divided by sine 85. Okay. So, if you actually do that on your calculator, you get 240 times sine 50 divided by sine 85, which is equal to 184.55. So this is approximately 184.55 meters. Now we know that in this triangle here, we know that sine of angle Q is equal to the opposite side, which is H, divided by the hypotenuse, which is P. So I know that H is equal to P sine Q. Now P was 184.55 meters times sine of Q, and angle Q is 45 degrees. And if you do that on your calculator, you'll get 184.55 times sine 45 is 130.5 approximately. So this is approximately 130.5 meters. So last thing that we need to do is, since this is a word problem, we'll write a therefore statement. Therefore, the height of the tower is 130.5 meters.